Okay, so I started the stream already, Sarah, so hey everyone. Well, I think it buffers. So we can wait. And let's check. Oh, there it is. Just make sure you mute it. I don't know if... Alright, hello everyone. So to give a quick introduction of what this video and this stream's about, I'm going to be chatting and walking through... Oh, hey Cody. I'm going to be chatting and walking through with Sarah the basics of Swift and going through some examples, going through the book, the Swift book, that's provided in the the description right there, docs.swift.org book. That's what I'll be going through and going through examples and kind of giving a basic introduction into Swift. So Sarah, do you want to say anything or give an introduction?
Hi, I'm Sarah. I'm a college kid.
There you go. That's great. All right. Can you see the stream, Sarah? Okay, cool. So for everyone watching the stream, I will have up the basics for Swift document up. But as I said, it's provided in the description. So if you want to follow along, they'll be in there. But really, I'm going to be skipping quite a bit of this text, going to specific parts that I want to talk about that are kind of features or anything of that. And then showing it in this playground and moving from there and answering any questions if anyone has any, but hopefully this will be basic enough where we can just go through and not have too many questions. So Sarah, FYI, the stream will be a little behind for what I talk, so just know that. So for the first thing of Swift, well, let me give a little bit more of an introduction than just diving into the language, because some people might not know anything about Swift, and I just want to give a slight introduction. Hopefully you've done a little bit more research, but Swift is mainly used as Apple's primary language. Obviously, Objective-C is still in the underbellies and used quite a lot in a lot of apps and a lot of old Apple software like a Mac OS or iOS and watchOS or other ones like that. So Swift is more of a new language that came about 5 years ago in 2014, I think I remember, but or 15, I forget. Don't quote me on that. But it was introduced as more of a safe language, one that had optionals and a little bit more new features than Objective-C, because Objective-C was kind of a version of C++. So it was a slight layer on C, adding some new functionality and some new syntax. So Swift came in, and it allows us to easily write code for Apple software, like I said before, iOS, Mac OS, all those. But then also there's some popular frameworks for backend servers or APIs like Vapor or Perfect. And there's other uses for Swift in Linux or other things like that. But right now it's mainly used for Apple. There's one example for the other uses is there's a fork of TensorFlow or a fork of Swift for TensorFlow, and that has interoperability with Python. So if you know Swift or if you know Python, you can use TensorFlow. So that's obviously an avenue, but I haven't dove into that. I don't know anything about TensorFlow, so I'm not here to say anything about that. But going to Swift, do you have any questions, Sarah, for anything kind of going into Swift from an outsider with learning some other languages?
Why do you prefer Swift?
That's a good question. I prefer Swift mainly because for my job I need to use it, and it's a lot better than Objective C. So originally I was used to Objective C, and then going to Swift for the same thing and the same output is just like amazing. But why do I like it generally as a language?
Compared to because in my class we have to learn Flutter and whatnot because our professor says that's the best language to learn.
It adds up to little things, and I don't know how to tell someone to love a language because it's obviously the person's opinion on a language, but what a few things are I don't know. It's just simple things of I like how it's written. I like how it reads. It drops the things that I was annoyed to write, like semicolons and parentheses and ifs and fors. It has really cool shortcuts, but it goes beyond that by being more of a high level language where it kind of changes the code beneath you with the compiler. The compiler is pretty unique. The memory management for Swift is not garbage collection or anything like that. It's ARC, or automatic reference counting, which I'll dive into later, but it's a very interesting form of memory management. And it's really easy to deal with. There's a few problems, of course, but they're common problems that are easy to avoid if you know how to avoid them. But yeah, that's why I like Swift. That's kind of the convoluted way, and I guess you'll see more going through the basics of it. Do you have any more questions?
No.
All right, cool. Well, let's dive in. No more stalling. So if we start looking at declaring constants and variables, that's the two ways you can declare a variable or something that has a value. A constant is one that can't be changed. So if I create a constant pi and I give it the value of 3.14, then we can see that pi has the value of 3.14. It's a constant because I can't change it. And you'll see the compiler kind of tells me cannot assign to constant. It tells me to change the let to a var to let me change that. Okay, so a variable can have its value mutated or changed. So we don't want that. We want pi right there. And let's say name equals Leif. Okay, so we can change the name or we can mutate the name now. So let's change the name to Bob. And we can see on the right after it runs it that the name's now Bob. Okay, so that's just basic of that. We have constants that we can't change, and we have variables that we can change. Okay, let me just comment this. I'm gonna make this document public on GitHub so that people can just clone it or check it out online after too, and I'll link it in the description. So the last thing on declaring constants and variables is that you can do the short syntax right here, where you just comma them out and do all the equals. Right? Anything on that, Sarah?
Mine doesn't have the fun little side things.
Oh, this thing?
The Leif 3.14 with the square little boxes next to it.
Are you on Xcode 11 or Xcode? Which Xcode?
That is a great question. I have no clue.
If you go to About Xcode.
Xcode 11.
Okay, cool. You should see if you click right here on this little view.
Mm-hmm.
Click on Live View. And does that show it up?
No. Sadly.
Okay.
Well, alright.
Alright. Well, you might not be in auto run mode, in which that case, if you're not in automatic run mode, which is right here, you might be in manual. You'll see a little run button on the left, and if you click that, it'll run the code. I'm in automatically run,
There we go.
and that just runs it every time after I save or that stuff, which takes a while after a bit. So hopefully that clears up that. And can you see now?
Yeah.
Okay, awesome. So, I don't know if you have any questions on that, but we'll just move ahead to type annotations. So everything that we made before has a type, and Swift compiler will automatically infer the type with the type inference, and this is good and bad. It's good because it's really easy to write all those before where I don't care really what the value's type is. It's automatically inferred. 3.14 is a double. Leif and Bob are strings. And 0.0 is a double. So those are automatically inferred. But you can redundantly save these ones, and this is oh, I don't know why I copied that. This is how you do that. But as I said, as these are all inferred automatically, it doesn't really matter. Let's give an example where I guess it might matter more, where I want a string and I don't pass it. Oh my, I can't type. And I want to pass it a string and I give it some integer. Well, hopefully that doesn't pass. Oh, I already have an X, and I'll just put 2's on all these because they're doubled. So yeah, it says that we can't convert an int to a string. Everything in Swift has a description, or not everything, I'm sorry. A lot of things in Swift will inherit or extend from string representable, which means that it can have a description that is a string, and I'll just show you this really quick. So it's just a variable that's a string, and it just uses to represent a string. So otherwise, that doesn't pass. Does that make sense, Sarah?
Not a whole lot, but alright.
What doesn't make sense? The variable that I was using, or that you can't have int as a string.
Well, I'm just I know from like previous experience, like you can't just like change a string into an int without parsing. But why? Like, because you can declare your constants and variables without having like doubles and strings and assigning to them. Like, when would you have to actually like assign that you like say like you want pi be a double versus letting it just use it?
Great question. No, that's great, and that's what I was about to lead into, is that you can obviously at the beginning of a class or a struct or anything that we're making, we can define these variables like let me give it age, int, oops, and you can obviously just leave it there. Now in the playground, it doesn't really like that, and let me see why. Let's see if it tells us why. And I hope to get to that earlier, but yeah, right here they're saying that you can declare values types by just saying what they are, and then you can expect them later to be that. Swift is a statically typed language, so once the type is set on that variable, it's that type. So it's not like, oh, okay, I set name as Leif and I can change it to 5 and now it switches. Swift isn't like that. This will actually error out. So knowing that, you can set the types and then you can change them later. Now I'm gonna, that actually does pass. I'm surprised. Normally in Swift, scope matters, and Swift has optionality, or here in a sec. I'm just checking up. Yeah, Sarah, you're a little quiet. I'm just checking the YouTube chat. Yeah, some people are saying you're a little hard to hear. Yeah, and this is extreme, like, beginner of just going basically through the language, but also kind of other programming languages. So hopefully it transfers a little if you know a little experience from another one. But yeah, we're just slowly going through it. But the next one is naming constants and variables. Swift allows for any of the Unicode characters, so you can have the pi symbol, or you can even have emojis in the code, or actually for the variable names. I don't really recommend this that much, especially since I don't know how to type that with the alt keys in my head, but yeah, know that's available to you. I'm trying to check. Alright. Going on to a really simple kind of how Hello World works. How to print in Swift, and it's just print. We got a function for print. There's a few different types of ways to print. So we can just say hello world. Oops. And we'll check out the other ways to print. So if we just type in print, Xcode will let us know what other prints we have. We can print in multiple different items. We can put them with a separator, and we can also put the terminator. But what I mean by separate items is that we can put hello world. And this is just another feature of Swift that I'll touch on a little bit later. But since I saw that print has the ... that doesn't mean it's truncated or anything like that. That means that it will take an array, but you can just list them out on here. So it'll just take up to, I think, like 9 or 12 of these as parameters. So you can keep listing them out until, like, I think it runs out, because for some reason they actually put out all the variables in the cases for the parameters, which is a little funny. But for the other thing of that, string interpolation. I can't talk. String interpolation. Jeez. That took a bit. So if we want to put a string in, or a variable or anything in here, all we have to do is the slash and then parentheses, and then we can put the name. And I'm actually changing the wrong name right there, but that doesn't matter. And you'll see that it'll show up right here. Oops. Jeez. And for this print, it automatically comes with a new line. That's why you have access to the terminator, because you can change that to not a new line. Does that make sense, Sarah? It's just basic print, I assume. I'm just going through it just to go through it for anyone that may have questions or anything like that. This is fun. I'm using comments for comments. So comments, single, basic like that. And then multi-line, just like that. Documented. Whoa. Documentation.
Question.
Oh, yep.
So for the, am I loud enough for people? Because I couldn't find a way to make my audio louder. Ooh, that's loud.
I can just turn you up. There you go.
Okay.
Let's try that. Maybe that's not my fault. Keep going, sorry.
So for the print, it's adding the \n, which makes it a new line. Is there a way to use a print that doesn't have a new line?
Yep. Okay. So I'll show an example of that. So that's that right. This one. So if we put hello, we don't have to put a separator, and then we just put an empty string. We don't get that new line anymore. Does it make sense?
I'm behind a little, so I'm.
Oh, yep. No, sorry, I forget. Someone's fan's loud. Sorry, my MacBook Pro is going ham on this for some reason. I'll try to move it away.
So just to fix the \n, you use the terminator?
Yep. And then that allows me to print like multiple things on one line. So yeah, we don't have the print line. We just have print that automatically does a line. So, oh, yep. So for Swift, moving on if you don't have any more questions or... Yep. Thank you, Sabian, for commenting. The default separator and terminator are those. And I'll touch on a little bit later default values or default parameters, values for parameters in Swift. But yeah, we'll just go through this. So for their example, Swift has optional semicolons, so you can put semicolons at any point of the line, and it will end the line of execution. So if I don't have this, it won't execute. Sorry, I was reading someone's comment in the chat, and not Swift related, but the new MacBook Air would be a great laptop for getting into Swift with Xcode, or should I get the Pro? That's always a tough answer, and I don't know. It always comes down to how much money you want to invest in the laptop and how much money you want to invest in really just running Xcode. Because that's what I've come down to realize is if you're getting a Mac to run Swift, like, yeah, you get to do iOS and all of that, but yeah. If you're down for it, yeah, get it. But a Pro might be a better long-term investment. But yeah, feel free to message me after. I'd love to talk about more. I have a short answer on stream, so I apologize for that. So quickly, yeah, integers are 32-bit signed. But yeah, we have other options for other ones, but they're default. No problem. Thanks for the great question. I get that question a lot, and it's really tough, especially when they come out with a new MacBook Air and they're advertising a lot. But yep, in integers you have mins and max, or I think in doubles too you have mins and max. So min value. Yep, so you can just use any value and you'll, oh, that's a very small value. Wow, I don't want to do that. We'll check out the max double. Oh. Well, that's sad. That'd be fun. But yeah. So those are those max values right there, and I guess you just get them all for all the integers. So if you wanted 8 or 32, even 64. I wonder how much. I don't know what the highest they go up. I forget. Don't really mess with that. Just mainly use the normal int. So yeah, just scrolling through this really quick. This is something I want to touch on really quick. So let sum equals 5 plus 0.5. Pretty basic. Now the question is, can Swift infer the types right there? Okay, so Swift can take these two different values and add them together. But if I do the same thing right here, I forget, I get a lot of typecasting errors for Swift on like this issue. And it might be different float values that I'm thinking of. But we'll see. Why does it take so long to build? Did that break? Is that running on yours, Sarah?
What, YouTube?
No. Are you following along on your laptop?
Yeah, you're just a bit behind.
Okay. Are you able to do let A5 be 0, 5 and then add them?
Hold on. No, it doesn't like it.
Yeah, so what you'd have to do is you'd have to cast A as a double and then add them. But yeah, okay, so now it's running. Thank you for that. That's where, pulling back to Zach's question, I have an okay Mac, and this still runs slow for just like one Xcode, so it may be just Xcode runs slow on any Mac. I don't know. I use Xcode so much where it's ridiculous. But yeah, does that answer that? Have any questions for that? I guess that wasn't even a question. But yeah, so then sum 2 would be a double. And so if you ever want to know the type, you can use the global type function that will give you the type. And then also, if you alt-click on any of these using Xcode, it will give you the declaration and the type and everything. So that's just a little bit more info about that. Some basic things on numeric literals. There's binary, octal, and hexadecimal. And then just default is decimal. And then yeah, you can use these for if you want to do commas. You can use underscores. Let's scroll through this. A lot of number stuff, geez. Okay, so quickly, type alias is pretty simple. So if you type in type alias, you can type in the new name that you want to name something. So let's do, I guess we can just do the example what they do. I was trying to think of something, but everything I think is just a bad example. So we can do a type alias audio sample, and audio sample is equal to uint 16, which is unsigned int 16. So then if I do sample value equals audio sample. Well, now I can give it a value of an integer, and it will work because technically the type is still the same. So that's type alias really quick, just really simple, kind of hiding the type or changing that. Booleans, oh, that's the thing. So for Booleans, they're like this in any language. I surprised that, oh, I guess they have conditions in that, so that makes sense. So we have some Booleans, oranges are orange, that's true, and turnips are delicious. That could be true if you like them. But we'll take from their code example and we'll do a conditional. So for Swift conditionals, they're just like normal ones like this, like this, I guess, where it's just if and then the Boolean condition here, and then whatever you want to happen. I'm sorry, I was reading the chat there. Yep, that's correct. A type alias is a nickname you give to a type. I think that's a great little summary of it. So, oops, jeez. So if we just print turnips are delicious, yes, and then else we can print whatever. Now Swift does have optional parentheses, of course, on this, so if you are super used to this and you are wanting to write that, that's optional, but just not a lot of people write that in Swift. So yeah, that's just basic if and else. I'm just going to copy this over. Yep, so Swift doesn't have truthy and falsy values, meaning that if the value exists and you put it in a if statement, it's true, or if 1 converts to true. So in the example, they give if I then do something, and in C, I'm pretty sure you did int I, it would work, but if you do if 1, that's true, and it would go into the block. So this doesn't actually work in Swift. You'd have to do I equals 1 or something like that, or 1 equals 1. But really I comes in here as a value and not, since the value exists, it's true. That's like that in other languages like Ruby, but not in Swift. Any questions on that, Sarah?
Nope.
All right, cool. Checking chat really quick. All right, I think we're good. So moving on, Swift has tuples, which are just different values or variables grouped together. So everything that we went over before, if I had a string and I had a double and I wanted to group those two values together, I could do that with a tuple. So for the example that they give, they wrap an int and a string together for error response with the error code, and then the string for what the error means. So if we just do HTTP 404, we can initiate the tuple by giving the parentheses and then really just list out the values. So as they said, you can have 3 ints, a string and a bool, an int and a string. So in this case, we're just gonna type in some numbers and then give it a string. I don't really care what the string is, sorry for that. But yeah, this is a tuple that's an int and a string. And I can add an array of some things. And now it's an array of any. So it's a tuple with an int, a string, and an array of any. If I get rid of one of these, then the array will settle down and actually pick what type it is. So the difference between single, or I guess double question mark and triple question mark is double question mark and I'm going to talk from the aspect of Swift, and this is foreshadowing on later. Double question mark uses the equatable function for a value, or it uses the equals function. This actually checks if the address is the same. So this will make sure that whatever you are talking about, those two things are exactly the same, and it checks that by address location, I'm pretty sure. But I'll touch on the other one later. Great question, and I think Sabian touched on that a little bit more. So touching on this a little more of tuples, they have a great example of decouplation, decompose the tuple. So if I wanted to get the values out of this, and let's say I only cared about the first one, then I can say status code, and I can just put an underscore for the second, and I won't get that value. But in our case, we put another array, so we need to put another underscore to ignore not the second, not just the second, but also the third. Otherwise, it'll give us an error. If we don't, we can put in one and get an array, and then we can use an array. I'll let that catch up, and if you have any questions, Sarah, let me know. But the last two things about tuples are that you can get the, let's say for our case, we can get the status code by referencing the values in two different ways. We can reference them default by int in the way they're ordered. So we put the status code in first, so that's 0. So that's how I know that. But that's not really a good way. So if we actually take this again and we do this, but we give a code like this, then we can actually give a named tuple. And now I can get the status code from the HTTP2 by saying code instead of that. So you can name your tuple variables and actually use them, which are pretty nice. So handy, but we also have structs in Swift that are almost identical to this kind of functionality of easiness of just grouping values together. So I'll touch on that later. But tuples are great for enums. We have really powerful enums in Swift, and they're not just 0, 1, 2, 3, 4. They're not just strings, but they can take in pretty much a tuple of values, and you can use them in the cases later on. So it's really handy. Going on to a very interesting topic of newer languages, and kind of going back on.
Question.
Yes, Sarah.
So is tuple basically just like kind of an array? Or like, because I'm a little confused like when you would use a tuple.
Yes. So a tuple is pretty much like an array. That's a good way to put it. Other than it doesn't have like an indice, they're already indexed for you. So when you get a tuple, you already know the size and you already know the types of the variables in them. So that's different than just an array. Does that make sense?
A little.
So
It's not crystal.
yeah, and I'll touch on it more later when we go over enums, when you'd want to use something like this, because I don't advise anyone to just keep passing around tuples. Like I said at the very end of the little thing of tuples, we have structs for this. We have, data structures for this. Like, tuples are really nice. They're handy, but they're mainly used for enum types. Does that answer that? It seems like you and Zach are on kind of the same question of like where to use them, and also I guess if they're an array. Yes, they're kind of like an array. Just to reiterate. Yep. Let's touch on tuples a little bit later when we touch on enums. I just kind of want to go in order of this for chronological. So going on to optionals, Swift and a lot of other languages handle nil or null. If you know it in Java or other languages, they handle null differently. They say that if a variable is non-optional equals 5, or non-optional equals an int and it's 5. The reason I know it's not an optional is because of int right here. And what I mean by that is if I say this is optional, well then it will have a question mark after the type. So any type can be optional, and what optional means is it might be nil. So I'm going to try to put both of these to nil, and one of these is not going to like it, and that's going to be the non-optional one. Yeah, now it's crashing. So if I change this to 5 and give the non-optional a value, well then it all works, and that's because optional lets you set things to nil or not have a value for a specific amount of time. So if I wanted to use this optional, I can print both of these, and we're going to see different outputs from both of these. It keeps putting this big one. So one, we're going to see kind of a wrapping, and the wrapping is saying optional 5. So that's because it is optional, it's kind of wrapped as an optional. So in Swift we call it unwrapping, and here's where they're saying kind of nil. You can have a nil value, you can set it to nil, and then unwrapping and force unwrapping. So in logical if statements or anything like that, if it's optional, you can check if it's nil. So is optional nil, and this will check if is nil. And so right now this would be no, it would be false because we've given it a value. But when I switch this optional value to nil, well, I mean, it's kind of redundant because you see it in both places. So yeah, it is nil at that point. But that also means if I don't give it a value, it's also nil. Okay, so that's just a basic if statement right there. But to unwrap this value, then all we need to do is give it an exclamation mark. Now this is technically unsafe. If the value is nil, this will crash. And let's see, it runs fine. Okay, we just see 7. Everything's fine. But let's say the optional value is not there. We get an error, and it's not a good error. It will crash the app or whatever thing you're making. So just make sure that you don't really use these exclamation marks or force unwraps as we call them. you can optionally unwrap anything, and as long as you return the same type, you'll be fine. So I'm returning an int because I'm being passed in an int. So if this is nil, then it'll just default to this 0 that I give it. Does that make sense?
Question.
Yes.
When would you want to use the exclamation point? Because you're saying it's unsafe to use it. Like, when would you want to use it?
So there's a few times that you can use it. I mean, you can use it anywhere. I personally don't think you should use it because you can always defer to the safer methods. Although they might be a little bit longer, and I'll show some of them in a little bit after this. But if you know something's going to be there, and you're like absolutely sure, like, well, I guess it can't be a let because, I mean, it could, but I would have to set it right there. But if I want to say some variable, some known value, and it is a double, and I know it's going to be there, I can explicitly unwrap and say it. Now I think this is going to be removed from Swift, so this is also why I'm saying don't really use it. But this has been how a lot of things are done in UIKit are kind of like this. So, but now I can set the value to whatever, but this isn't treated as an optional. But it is an optional. So that's the weird part. So if I ever use this value and it is nil, it'll crash. The same thing as I said before. So that's kind of an example of where it's used. And that's used in UIKit, in making an iOS app, or other things like that. But mainly, you don't want to use it. And I hope they're trying to remove it more. But the explicitly unwrap is maybe you're testing and you don't maybe you just want to force unwrap a user because the user is optional and you don't want to create a default user. But that's a good question of why would you want to use the force unwrap when there's all these nice optional bindings in Swift. And I hope this is a good segue, so let me know if you still have questions. But Swift has optional bindings that you can do where I say if let some value, so some unwrapped value equals, oh, and the text is getting pretty good.
Before you
Yes.
go on your segue, just to clarify, what is it, like line 89 or line 90? That's or no, your line 88. That's a boolean that you're using that if optional is nil, it's true, and if not, it's false, right? That's just a weird way you're setting it up.
Yep, that's a boolean.
Okay, and then on your line 91, that's just a really those two question marks are just a short way to be like if it's not, like if there's nothing there, it's 0.
Yep.
Okay.
Yep, so that's just the default value. Sorry, I'm just reading Zach's message in there. Is it going to be removed? Will it be replaced or just straight removed? Sorry, I don't know what you mean by removed, but
I think he's talking about the exclamation point. How you were saying you were thinking it was going to get removed in the...
Oh, so sorry, I'm coughing over here. I need more water. Int is a type. It's int, okay? Optional is an optional int, but it's further than that. This is just language like sugar. This is just syntactic sugar, so I don't have to write optional int, okay? That's what it really means. So, sorry. Maybe I don't know. There's a way, or this, I don't know what type this is, but optional is a specific type, and you can see it right here. I'm sorry, I finally got some water. Thank you, honey. So yeah, this is actually a specific type. It's a forced unwrapped optional, and that's why they're going to remove this type. I don't think they're going to remove the explicit unwrapping like this. To touch on that, sorry. So for this optional binding, you can say if let some you can say if let some unwrapped value from this optional, and now I can actually use this value unwrapped. So that means that whatever's inside of this, you saw it right there, this is an int. This is an actual value, and it will always go, or no, it won't, sorry. It's not doing it because it's nil, and that's, this if statement will only execute the code inside of here if this is not nil. So I'll put 2. And now we should see 2 lines of 2, so 2 and 2. And that's because they do the same thing. So I can also do the else and do something completely different if it if the value is not there. And so I can say value not here. And so when I change this to nil, we'll get this else instead of the if. Okay. So moving on. Another thing I'll talk about really quick is, just because it kind of works here, you can do optionals like this, and you can chain ands by commas or by double ands. So in Swift we use a lot of commas to list out all of the rules or cases of why it came into this execution block or whatever, or why it's true. So first we say that optional needs to have a value so we can use this value inside of this block, and then we want to say that this is actually a double value, so we're going to say as a double. So we can do that, and there's a few different ways to cast in Swift. You can do the normal way of, well, I say normal, sorry. You can do int like that. You can just pass it into the constructor, or you can do as int. So there's many different ways, but the nice way about the as is everything I showed you before you can do to that. So this is probably not going to work because this as isn't really doing anything. It's going to say that we can't convert int to double. And that's kind of funny. I mean, it's really simple for us, like, okay, int doesn't have any decimals, so why can't you convert? Well, that's why you'd use the doubles constructor on an int. So if we want to use the as, we'll use the question mark, and then we'll unwrap it, and of course it doesn't show it, but when we put in 7, we'll have 7.0 as this one, or we don't. Questioning why. I thought it would point at 0, but I'm not going to touch on that more, but that's the as right there. And you can see them going into it a little bit more. And this is where they do multiple commas. So for this block, let these 2 values, and then this Boolean statement, and then it'll go into here. And then you can have multiple inside, and just more and more complex. And I'm not really going to get really into those unless someone has a question or an example they'd like to see. Oh, here we go. So what we were talking about before, implicitly unwrapped optionals are these exclamation marks. And we've kind of already talked about this, so I'm going to kind of skim over this. And yet we said you can do a Boolean statement on if something is nil or not. We can also do an if-let to use the value unwrapped. So let's think if we want to check something's nil, we can do it through an if. If we want to use it, we can do it through an if-let. There's also one more, and I hope they touch on it here soon because it's right by the if-let. It's commonly used. But we'll talk about error handling really quick, which is, I think, kind of simple in Swift. Yeah, and as Savian said, yeah, feel free to take note, and we will definitely elaborate them more in the Discord, and make sure that you definitely understand them. I'm just trying to rush over everything that I can in my limited time. So for error handling, functions can throw, and what that means is that at some point in the code, they can say throw some error, and we'll just say this code works. But if this happens, then whatever called this error or this function needs to handle it. And simply how you do that is if a function says it throws, you need to call it with a try. And you're going to get complaints about a try that it needs to be in a do catch. So some ways that you want to get around that is, well, what about if I don't care about the error? I can wrap this error as an optional and just do a try question mark and just say, hey, if it throws an error, just return me nil. Or I can force unwrap it and just ignore the do catch and just say, hey, crash on the error. So those are some other examples of where you use the optional or force unwrap. But if I want to catch the error and actually print out any error message, all I have to do is do a catch, and I don't even need to write anything. It already gives me the error as like error, like the text. So this is a parameter passed in, just like that. Any questions on that? I don't want to touch too long on this because this isn't really something that you use too much in beginner. So, and it really isn't that hard to use in Swift, especially since you can make them optionals. You can do a do catch, other things like that. I'm not going to touch on assertions since you can just do if statements or prints. But just noting this is on the right, this is how an if else works. And then also I'm not talking about preconditions. Okay, skimming through here, one sec. There's a lot of extra stuff. Do you have any questions, Sarah? I'm gonna jump to the core topics and kind of be finishing up soon.
I'm doing good. I have some errors on mine, though, which I'm trying to figure out.
Do you need me to scroll up or anything?
No, it says unresolved identifier of some error. And then it also wants me to add a semicolon somewhere that shouldn't have a semicolon, so it's just being touchy.
Yeah, so they're going to improve the compiler's errors soon. That's in the Swift evolution, so hopefully that comes in soon. So, to make a function in Swift, very easy. We just say func, the name, print something. And we're going to just put empty parentheses to indicate we don't take a value. And we're not going to return a value right now. So this is a function that you just call, and it does something without being given anything, and it doesn't return anything. So, whoa, can't type. Alright, so that's easy. And how we call that is just like this. So if we run it, I haven't defined the sum error, so it's giving me an error. Oh no, killed me Xcode. 1 second. Alright, I got it back. So that's how you call the print something or just a function with anything like that. So if we have a function that has a parameter or returns something, in this case both, you can say greeting message is greet person. We'll greet Sarah here. And so
Yay.
if we run this and it'll update. There we go. So now greeting message is a string because we return a string. So for Swift, you name the variable or the parameter that you want to take in, and then you give it a semicolon, and then you say the type. After this, you can give it an optional value so that you could run it without the parameter. And you'll see we print out hello nil. So that's that. Do you have any questions about that, Sarah? If we wanted to add more, it's just oops, that's too big. But yeah, we can add more exactly the same, just with commas and that stuff. Alright, yeah, I don't want to touch too long on that. Yeah, functions without parameters. Just removing this. That's a function without a parameter. Pretty basic on that. Multiple parameters, yeah, comment out. No return. Just remove this as we did in the first one. Yes, Xcode, you crashed a while ago. Thanks for the report. So here's a little bit more complicated one. I don't know if you want to talk on these too long and just going into functions, or if there's any really questions on functions, but this is probably the last one I'll talk about for a function. This is minmax, takes an array of integers, and it returns a tuple with variables named min and max. So that's a case where you might want to use a tuple to return just a small set of data that's relative to whatever the function does or whatever the data provided, makes sense. Yeah, and then it's just talking about optional return types. So obviously values can be optional. So if you return an optional, well, maybe if let's see if this optional is nil. Maybe if this optional is nil, we return nil. Whoops. And so the only reason I can return nil from this function is because this is an optional, and so that means that this is an optional. Greeting message is optional. If it doesn't have this, then well, I'm going to get an error because I can't return nil from something that's not an optional. So you can obviously do that to tuples. You could do that to each value in a tuple, I'm pretty sure. Maybe. Don't quote me on that. Here, let's check. So if I do int... Oh yeah, I think you could. So then if I do greeting message, yeah. Yep, so you can do ints like that. And so a new thing with Swift that we just got in 5.2 is functions have implicit return. So you can make a function that returns something, and we'll just call it a one-liner. Not an exclamation mark, sorry, I got excited there. We'll return a string. Now in Swift 5.2, you don't even need to put return. You can just say the string. And so Swift also has calculated variables. So you can also do that same exact thing from a variable. So just how you call it is one with a exclamation, or one with parentheses and one without. So that's the difference with that. But both of those will be the same value, both saying hello world. But yeah, if the block of code is returning something and it's one line, you don't need return anymore. So I mean, you can still add it. But this is just one of the nice things that they added in Swift to reduce the repetitive returns for one line. Function arguments really quick. Oh, jeez, I ran out of ones with actual things. Parameters, that's what that word is. So we'll just do a test. We can do calling name and then just normal name, I guess. So when I use this function, the reason I put calling name is because when I call this function, this is the name of the parameter that I'll see. But when I'm using the function inside, the second name is the one that I use. So when I put in test, I get calling name as required to put. Okay. You can also, as I talked before, you can also just omit that and say, I don't care for the name. And we'll get an error saying extraneous argument. It doesn't require the argument label for that. So that's all they're talking about that, and that's what they're talking about right here, of omitting the argument label. Oh, and then we already talked about default value. So if I wanted to give a default value for the name, then I can call this, and that's that prints no name. I can also just give it a value, and I'll print the name for that. So variadic parameters are what we talked about before in the very beginning. They let you take in as many values as you want, pretty much. So if I wanted to make a function that takes in values, and they're all integers, and they're variadic with this, I'll return an int. Then I'm trying to think. We'll just do that. Yeah, I guess we'll just do what they did. Var the sum equals 0 for values, or for value in values. This is how you do a for in, which is kind of the main way to do for loops now. They removed the C for loop, which I'll show you an example of that. But sum plus equals value. Yeah, they really moved away from kind of C. They even removed, you can't do this, the plus plus. They removed that. So that's the main reason you can't do the for loop. But yeah, they don't really allow for loops. You have to do, you have to use ranges. So for in a range. And so boom, we'll just do this. And so for the sum now, I can pass in 5 and 6. All right, cool. That's 11. And now I can pass in a ton more values. And oops. And it'll just keep taking them. Any questions on that, Sarah?
You're typing real fast.
I feel bad for my keyboard. Okay. Are you caught up? Sorry.
Get in there.
Okay, cool.
Okay.
Okay. Good?
Why does yours have the fun little, like, shows, like, the hello world and, like, that little, like, I don't know, like, highlighted stuff? Why is yours so fancy?
Oh, so if you click the show result button on the right, it will constantly show the result on the next line.
Oh.
Yep, so that's just how you keep it if you want to observe it. Okay, so we're going to do a basic one of the sum, but we're going to do kind of what they did over here, is add value A and value B and return an int. Okay, so then boom, just do that, and what I told you before is you don't even need that. Awesome. Okay, cool. We got that. Can we do this? Type of add, and this is pretty much what they're showing us, I think. Oh, it's not. Yes, there we go. Okay, so the type of, very cool, very powerful. We can pass in this function into the type of, and it will tell us that it is the type of a tuple that returns an int. So this is a tuple of ints, 2 ints, and it returns an int. So that's another answer of where tuples are used. It's actually used in the function right here. So you can think you're pretty much defining tuples right there, and you're accepting those in. Does that make sense?
Still a little confused.
What are you confused about?
Just the way you phrased it, it didn't really, like, stick in my head. I don't really quite know how I'm confused, but, like, that didn't make sense to me.
Okay, let's go through this again. So add, when we use it, let's get rid of this. Maybe this is confusing. Let's use add. We have A is 5 and B is 25. Okay? So we pass in A, which is an int, is 5. So A is an int, right? B is 25 int. And what do we expect out of this? We expect 30, okay? So then we return 30. And I'm just putting the types on the right. So, and I'm just saying this kind of redundantly, so I don't know if this will actually help you. But The type then would be, I'm like, and this is where it's kind of tough for me to explain because I just copy this. And what we talked about before is this is a closure, or this is a tuple, right? This is a named tuple. A and B and int. Or both ints. Sorry. I'll wait for the stream to catch up for you.
Thank you.
No problem. But yeah, no, like if you just copy the function declaration right after whatever you name it, so right after add, if you grab this, that is the type. You just strip this away, and then boom. That's exactly what type of told us. And we have a tuple that has two integers, and then this function will give us an int. So that's how it is. And the reason I'm saying this so much is because Swift uses functions a lot, but functions are also closures. And what I mean by that is if I have some function and I say, okay, so I have some function that is two ints and it returns an int. I can actually do some function equals add, and I can do the exact same thing I did to add, but on some function now. And this is the same. Oh, ha. So one little error, and that's because right here it doesn't have the names, but it will still return 30. Running. There we go. Cool. So that will return 30. And now some function is not really a function, but more of a closure. And so I'm going to skip through this because we've kind of talked about this. And yeah, so they start talking about right here, function types as parameter types. So Swift and quite a bit of other languages uses closures or lambdas or anything like that where they contain some block of functionality and they can either return or they can just return nothing or return void. And pretty much closures or lambdas and that stuff are in a sense unnamed function, but can still be saved to a variable, like a local scoped variable. So you can also take in a function as a parameter, as they're doing right here. They say print the math result. They take in a math function, and then they print the math result right here. So if we do this, then I can type in print math result. I can pass it in some function and say 10 and 15. And this works because the types line up. I passed it in an int right here, or in close. Okay, this is getting here. One sec. Let's use something else that we learned to make this a little just easier for the stream and for the eyes and video. So let's just name this a math function. And so now everything that we're dealing with is a math function. Okay, and that's just pretty weird because of that. So now I can pass in this math function, which is just a closure, and that's what I'm going to start calling this now, is once you see this syntax right here of a function type, that's pretty much, that is a closure. Okay, does that make sense, Sarah?
I'm still typing.
Okay, yeah, no problem, sorry. I'll wait up. There might be questions in the chat or anything. But functions and closures are very, very, very similar, but there's a slight difference in the fact that functions are defined out of scope or in scope and used accordingly, and variables are more of assigned a value, and that can be a closure, but it's more of a temporary value, not like at compile time or anything. It would be more of a runtime kind of passed in. It's like I have a function now. But closures are mainly used for callbacks and other things like that. If I call something and I want to do something at the end when it completes, then I might pass in a closure for on completion. So whenever something finishes, it would just run whatever I give it. That's just an example. Are you caught up or?
Yeah.
Okay, cool. All right. Any questions on closures and functions, Sarah?
No.
Okay. No problem. Good, you don't have any questions. So really quick, we have while loops. They're super simple. While boolean or while a statement, while in this case false because I don't want to break my computer. I don't advise doing true because sometimes it gets stuck. It's just while false, the same thing I can pass in like this, and it's very similar to other languages, but it's just a Boolean statement. You can also do a do while, but I won't show that. Another thing with Swift is they say nested functions right here, but they really mean nested anything. So you can have a function, and you can have an inner function, and this can call that, and then let's say we have another one. Which one can call that one? Yeah, so that's kind of how it works, and that's the scope. So you go into the function base, we define a private function inner inside of base that only inside base can reference, and then inside inner there's a very inner function that only inner can use, and base can't. So that's nested functions, but you can also do that with some class, and you can also do that with an enum, and it just goes on and on because you can always do anything inside of anything, really. So this is, I think, all valid. So yeah, in Swift I can have a function inside, or I guess a class inside of an enum, inside of a class, inside of a function, inside of a function, inside of a function. Don't do that, but just know that that's kind of how it's set up, so you can really kind of control the scope. If you want someone to use an enum, maybe you put it inside of your class and you only use it inside that class and let them reference it through that class. So any questions on using functions inside of functions or classes inside of classes or anything like that, Sarah?
Well, you just went from like 0 to 100 real quick with all of those functions inside of those functions.
And I'm making a point of that it is ridiculous and you really don't use it that much. But yeah, it is really weird. But yeah, you don't use it that much, or really that much ever. If you can stay away from it, then it's just better, but there may be the case. Really quickly, did I show you how to make an array? We'll just show you that really quick. I think I did in the beginning with that any array. There we go. So, just really quick, this is how you make an array. If you want to declare an array type, it's just brackets around the type. And if you wanted to create a empty array, there's like 2 different ways to do it. You can do just empty, or if you don't like the type, what do you combine? Oh, I already have an array. If you don't like the type declaration, you can do a shorthand like this, and this will create an empty array. But yeah, I think that's pretty much it for that simple little array thing. But yeah, closures, the syntax of them, if I wanted to create some, we'll do that, some closure, and then I can put it with curly brackets to define that it is a closure. This is a void to void closure. So it doesn't take a value and it doesn't return a value. But if I say that I wanted X in, and that's just the syntax of the return type and what you get. So I could say that's an int. I think at this point I need parentheses because this is the parameter that we're taking in. So in this case, if I know it's an int, then I can do x times 2. And I can call that closure and pass it in 3, and I'll get 6. So that's what I mean, that it gets really close to a function. But now I can pass this around more as a variable, but you can still do the same case as a function. And then it gets confusing, but just know that you really work with functions and you'll start to get more familiar with closures more and more. An example of where you'd use a closure is kind of how we had that array. If I have some array, can't type, and I go 1, and then I put in a ton of random numbers, and I want them sorted now. Well, Swift has a few high order functions that let you quickly do this, and this will just be a quick representation of a way to use closures. So if I wanted to sort this by a certain thing, so this is a function called sorted that returns an int array, and it accepts a parameter by, and that parameter is a closure that takes in 2 ints and returns a boolean and also throws. That's quite a lot. Know that we can do something simple like, okay, I want the left hand side to be less than the right hand side. Okay, so then when we look at this, oops, then we'll get 1, 2, 3, 4, 5, 6, 7, and then yep, all the big numbers in order. If we switch this to be, I want the left hand side to be bigger than the right hand side, then this will switch to the bigger numbers. Okay. Swift also has many different shorthands for this. You can just do sorted with less than, and this just needs the by argument. I'll touch on this a little, but feel free to message me more in the Discord about why this works. This works because this is a static function for int. And what I was talking about earlier is that the equals is also a function for int. So if I do 1 equal 5, it shows me that this is a static function for int. And potentially I could even jump to the definition, which I might not want to because it might take a bit and freeze my Xcode. There it is. Okay. So yeah, you can see it takes in a value, and I backed away because it was slow. But yeah, you can see those are actual functions that I'm calling and I'm using as kind of a closure. So closures and functions are very similar. I'm not going to touch on closures anymore because they are very expansive. And Swift is kind of weird with them, where if you have a function, this is the last thing I'll touch on it. If I have a function that takes a closure, you can see it calls it in two different ways. It calls it with the name, or the parameter name, like this, or a trailing closure, which means if the last the last parameter in a Swift function is a closure, then you can call it like this, where boom, it doesn't even have this parentheses, or I mean it doesn't even have the parameter. Potentially, yeah, you don't even need the parentheses, which make it even more confusing. Any questions on that? We don't have to stay on that for too long, Sarah.
I'm just typing.
I love it. Okay, well, let's. I'll just wait a bit. Let you catch up. There's just a few more things I would want to touch on. So.
Okay, I'm caught up.
Any questions?
Why did you have to make that function name so long?
Ask Apple. They made it. Some function that takes a closure. So, last data type that I'll touch on is dictionaries. So dictionaries are very, very much like arrays and how they're defined, like int, but we'll do a semicolon and then we'll put another value. And what this means is that we have a key int and a value string. So if we have the dictionary int to string, then I can add values by an integer that are strings. So that's kind of just basically how that works. This is in other languages. It's known as a map, or other terms. I'm trying to think. Dictionary, map, hash map, hash table maybe. But yeah, they come out as optional values because, I mean, you can put any value, and if the value is not there, then it is nil. So it's kind of weird because you define string. So when you use this, it gives you an optional hello, but you didn't say optional. But that's because the dictionary itself referencing it makes it optional. So if you made this optional, then you'd have an optional, which is kind of weird. But yeah, so that's dictionaries. Scrolling. Yeah. All right. So I think we can stop going on the guide right now, or jump over to enums. So there's 3 topics left: enums, protocols, and then kind of classes, structs, and extensions. And those are all kind of slightly related, so it won't take too long. but enums I said were very powerful in Swift. So what I mean by that is that we can have some enum, whoops, and we can say, let's say, what do we want? I'm trying to think. First, let's just go second, third. I was trying to think of cool food names or something like that, but is it case? I forget. Is it comma? For some reason, I always forget variables. I don't, or I not variables. I forget enums. I always forget the case, and yeah, you need case, and that's because some other languages have the nice thing of where you can just list the cases, but for Swift, if I wanted to print some enum second, well, what would it print out? Well, it actually prints out second right now because it defaults to string. So this enum is actually type string, which means that any of these have a raw value of string. So if I wanted these values to have int, then I could say that first starts at 6 and second would be what? Oh, is it? Okay. Oh, whoops. Bad example. Sorry. So it's just saying the type case right now. Raw value will actually say the whatever it is. Yep. So it doesn't have a raw value because I don't give it a thing or a type. So now that I say it's a string, now it's actually going to print out second. And there it prints out second. So then if I switch it to int and give first 6, then I'm pretty sure second should be 7. And that's because it goes 6, 7, 8. Whatever I start this value at, it'll just count the rest out. Okay, cool. So enums can be different values. But now what I was talking about before was enums can also take in a value on the case. So string with a name, and let's say we have another case with ID, and then value. So we have all these different cases that take in different enums, or different tuples for these different enum cases. So we'll just say let the first enum case, and we can pass in a value, and I'll only do the first and second because the third one is thirst. Oh.
I was wondering if you did that on purpose.
No, I'm just typing. I don't even know. So if we have the second, then we just give it some value. So this is kind of weird. We have cases that have values with them now. So let's say we have the second, and we have some enum, and we know it's going to be one of these, so we're going to use a switch, which I know I just pulled out of nowhere, but for the sense of time, I'm not going to talk about a switch too much. As always, just feel free to message me or ask any questions. I'll try to reply as much as I can, but we'll just pass in second, and we can pass in first. And so now we do this weird syntax right there, and I know that's a little weird, but we say case dot first, referring to here, and then we say let name. The let name actually lets us use that value inside of here, and then nothing. So we can pass in these cases, and then it can actually use it when it needs it. It's not going to print it out here, but if I do first, then we'll see that it actually prints out the name of the first case, which is HDFGH. Sorry for that. But yeah, that's enums really quick. Last thing I'd say is enums can have functions. I know I say that was a question, but it's more of, you don't really see enums that much with functions, but it's just the case that you could add functions to an enum or a class or anything like that. Just noting that if you wanted to have a function to make it easier to get the case out or to automatically do the switch that I'm doing right here. Any questions on that?
Why is it going straight to the default?
Oh, so it's not going to the default anymore, but it was first going to the default because we passed in some enum second, and we only put a switch statement case for the first. So to get the second, we need to do case dot second, and then do let ID and let value. And then we can use those in that. And again, if you didn't want to use the value, then you just put an underscore. Does that make sense?
Hold on, I'm typing.
Okay, cool. I shared the Discord link in there for all you guys. Yeah, feel free to message me or let me know any questions. This will hopefully be a continued stream, our series on Swift, going more advanced and into more topics of what you can use with it and answering any questions anyone has. All right, Sarah, are you caught up or what's up?
Yeah, I've got it.
Awesome. Okay, so we did switch. Oh, look, we're just jumping ahead. So yeah, we use switch with cases to get through those. I'll talk about different ways to use these in the more advanced talk and other syntax to do that, but I'm just scrolling through here now. Yeah, structures and classes. Awesome. The last big topic I want to talk about. Okay, so let's say we have some object, and this is a tuple. The tuple is id int, name string, and then age int. And we'll actually make that. Okay. So we could use tuples. We could use tuples everywhere. You know, that'd be fine. But we can get the same kind of structure and everything that we did right there by making a struct of it, like let's say a user object. So if we do a struct and then we just define the variables that we want with their names and types, then I get the exact same functionality of that, but a little bit better of that I don't have to type out this huge type right here. Let some user, well, be a user, and, you know, user equals boom. And then I automatically get a constructor. I don't have to make a constructor for a struct. I have to make one for a class, but not for a struct. So that's a struct right there. And really quick, I'll show you a class of kind of the same thing. Oh, sorry. Okay, I didn't know the Reddit post one didn't work. Did the one that I shared in YouTube work? Let me know otherwise. I'll make sure to get the invite here. Also, if you just go to oneleaf.com, our organization has our website under development, and we have a Discord link that should work in there. So try that out. So if we do a class user with the same thing as struct, we'll get an error, and that pretty much means that these values haven't been initialized, and it will try to do a default initialization. So if I add just a default value to all these, then that will be fine. Or instead of that, I can add in an init and then say ID string, name string, and then type all these out. And let's say I don't want to do age, I want to make age default. Then pretty much this is how you make the initializer for Swift. And this is for structs too. You can make an initializer for structs. So then I can create a user by doing class user and then just passing an ID and a string. So the difference between a class and a struct is, and still staying on more of basic talk about Swift and not getting into the underbelly of it, is a struct is a value type and a class is a reference type. So anytime I change some user, let's say I make a function inside of user that is change let's say let's have a function called birthday. So if I have a function called birthday that adds 1 to my age, that's fine. But actually, this kind of freaks out with structs, and it asks you to put mutating in front of the func. And that's because once you do some user dot birthday, it actually does a little copy on write. So it will add it and actually update it because it's in the scope, but it mutated this, and that's why it has to add this, because it actually had to recreate this value because of the reference. And I'm not going to get into that too much, but just know that if you do the same thing in here, you don't need mutating. Okay? Any questions on that?
Nope, I think I'm with you on this one.
Cool. All right. So one kind of last thing about classes is that you can extend from multiple different sources, and structs are only extended from protocols. So what is a protocol? Well, protocols are kind of blueprints to what defines something. So let's say I have I don't know, a talkable protocol, and talkable means that, oh my goodness, that it comes with a function talk that returns a string. Okay? Well, what does that mean? That means that I can extend from talkable, and I need to move this up or down. So if I extend class user from talkable, then I'll get an error and it'll give me talk. So if I return the name and then the person saying hello, then I can have us dot talk say, if it builds, oh, there it is. Yep, sorry. It returns it right here. So if FASTA said hello. Okay, does that make sense, Sarah, for a protocol?
Nope, I'm lost now.
Okay. So you know what an interface is?
Sure.
So an interface in Java is kind of this is similar. It just defines things that should be there. So if I did us is not a class user, but us is talkable, well, anytime I reference us, it's talkable now, and all I know is it can talk. Versus if I don't do that and I use us, then I can get the age, birthday, name, and other things. So class user is in some way talkable, and it can be referenced as talkable. Does that make sense?
I think I'm missing code.
Here, let me try to do here, you look a little bit. I'm reading chat. We have someone that said, I just joined and they're asking if I've covered closures yet. I can't seem to wrap my head about the concept and it drives them insane. I talked about closures already. There's a link in the Discord. I think it'd be better if you and I just chatted in the Discord because I can really just answer your question instead of just talking about closures for a while. I would love to focus on closures in the next stream, a little bit more advanced Swift topics. So check the links in the stream chat to join the Discord server and message me. I'd love to chat. Great question. So moving back onto the topic of protocols. Protocols are a way to define functionality for a class or a struct. So I can do this, Sarah. I can make the user, oops. Sorry, I'm moving around code. I can make the struct user also extend from talkable. Okay, so now it says it doesn't conform, and that's because of this talk function. Okay, so both need to conform to the talk function. So that's why they're both talkable, because anything that extends from talkable or any protocol has to have anything defined in here. So the fact that user is talkable and the fact that class user is talkable, both of them I can do talk, and I think I named some user. So both have that functionality, and I know that because of talkable. Now if I got rid of talkable and did this, yeah, they can both have talk, but I don't know that they have talk. Does that make sense?
Are you talking to me again?
Yes, you're my guinea pig.
Well, you're copying and pasting code so fast that I don't know where it's going.
Oh no, I'm sorry. It's kind of big too. But yeah, just know that protocols are for defining functionality and variables or functions for a struct or a closure.
Okay.
All right. Last thing I want to touch on, and last thing for the stream, and this is more of a trailing topic of I'm going to introduce it. I'm going to talk about it a little. I don't want to touch too long on it because it's going to be my intro for the next talk. So Swift allows you to have what they call extensions, and so an extension is a little bit newer of a topic. And really quick, sorry, Elijah, I'm gonna butcher your name. I'm so sorry. Yes, the Discord or the Reddit Discord link is wrong. If you want to go to oneleaf.com, or if you want to scroll up and check the Discord link in the chat of the YouTube, that should work. Yeah, sorry about that. But yeah, going back to what Swift has as extensions is you can extend any type in Swift. To show you that, we see talkable right now, and I see talkable has talk, but what about speak? So for Swift, it's pretty weird. You can go into talkable and say extension talkable, and say that there is a function called speak. Whoops. And you can just define it and say it just prints out. And so now I can do us.speak, or I can do some user.speak, and both of them get it from this extension. If the extension's not here, then both of them don't have access to it because it doesn't exist. The extensions allow me to add functions to pretty much any type. Does that make sense, Sarah?
Sure.
Yeah, functions are extensions are really weird. An example that I've seen before is that you can make a calculated variable for like banana on a string, and well, since we're extending on string, we can just change every, replace. Oh, do they not have it? Oh, whatever. We'll just say banana. So now, if I do my name is, and then this variable, this calculated variable, because I can't set it and it only returns something, well, value string will not be my name is, it will be banana. I could also do a little string interpolation, and then I get, well, sorry, not, we don't want to do $0. I'll touch on that on the next one. But if I do self, I'll refer to the string itself, and whenever this wants to load, boom, my name is banana, and that's because it uses self, the string. So I'm referring to this in here. So self is my name is, and then I'm returning that. So we have a question for what's the difference between class and struct. So that is a topic I'll touch on a little bit more in depth in the next stream. But again, I'll repeat what I said before. Of class and a struct are different because I'll just write this out. a struct is a value type. Class is a reference type. And a struct can only extend from protocols. And a class can extend from protocols or other classes. There's other things, like I said, I'll get into more of how the data is handled. More of structs are write on copy, meaning that the value isn't shared between instances of references. They're all separate. Oh, okay. I'll touch on that really quick. Jumping back, I'm just not gonna say your name. I'm sorry. We have a question in chat for what is $0? So let's say I have an array of values. We'll just go 1, 2, 3, 4, and I want to change this array, and I want to double every value. All right. So I can do this using a higher order function called map, where I pass it a closure. So this block right here, this 2 curly braces, is a closure that takes in an int and returns some value. Okay. So if I do $0 in here times 2, well, then this doubled array will be exactly what I think it to be. Oh, come on. It gives me a graph. That's handy when I don't need it. So if I actually print out the doubled array, then it's doubled. The $0 just refers to the 0 index parameter. So I could change $0 to value if by doing value in and then changing the $0 to value. And then you should see it right here. $0 is the first one, $1 would be the second, and so on and so on. But you can also name those whatever you want inside that block. So that was the really quick side combo of $0 and struct and class. Any more questions on extensions or anything else about the talk? I think that'll be all for this. This was about a 2-hour discussion on the very basics of Swift and intro. So please let me know if you do have any questions. If you do and you don't want to ask them here, or if you have any questions later and you watch this, feel free to message me in the Discord. I will put the Discord link and the oneleaf.com link in the description. But other than that, I think that's all. Sarah, did you have any questions?
I have a lot of questions, but that can be for later.
Okay, any that you want to just get right out of the way? Otherwise, yeah, feel free to message me and we can talk later after this too. I know this was kind of long.
No, I'm good for now.
Okay. Okay, we got a few more questions, so I'm just gonna finish up any questions in chat and then we'll end this. It kind of works like the index of a for loop. Yeah, kinda. You can think of $0 as the same thing as if I make a tuple and I want to reference, the second value, or the second value would be 1 because this is 0, 1, 2. We have a question, what does valid type mean? Valid type, I'll be using that a lot and you'll hear that a lot, means that if I have a function that takes in a value, that value accepts a type, and that's an int. So when I'm using this function, I need to pass in a valid type of an int, which is an int. It could also be other things. So if it wasn't an int and it was a double, I could pass in a valid type of 54.6, but technically I could also pass in a double because an int, I could pass in an int for a double because an int's a double. So that's what I mean valid type, because some types fall under the umbrella of other types. I hope that makes sense, but again, message me in Discord. I would love to chat more about this, and I'll continue the stream. So, yeah. Is there any other questions? Awesome. Well, I think I'll wrap this up. Thank you so much for your time, Sarah. I know it was a little bit longer than I expected, at least.
Yeah, now I have to go do homework.
Yeah, I feel bad. Good luck trying to get that done in time.
I'll just email for an extension, it's fine.
There you go. All right, awesome. Thanks you for everyone that's watching. Feel free to join OneLeaf at oneleaf.com. Like and subscribe. I'm supposed to say that for YouTube. And always have fun. Bye.